It's just amazing. You know, I saw Dan's talk. I think that was a wonderful presentation, but it also just illustrates the beauty of ANCSA and consortia studies like this. You can bring a lot of different people with different perspective, different instruments, different tools, and combine them to better understand the samples. And utilizing this sort of data, it enriches the sample information and data that you collect. And in the same token, it also provides the samples provide ground truth. And what I'm going to be focusing on today is the lithic fragments that we have found within the core. This is just 73001 XCT imaging going down the core. And you can see these wonderful clasts that occur in the core. Again, they're just beautiful. And I'll show some other just wonderful images of these. And these range from a variety of volcanic and other magmatic rocks, plutonic rocks, perhaps, through a variety of impact melts and breccias and pyroclastic glass beads. So it's a treasure trove of material. What we did very early in the ANCSA initiative, we put together a lithic fragment analysis group that provided guidance and outlines for how we were going to handle the various lithic fragments and highlighting and identifying those lithic fragments that were of high priority. And then we started moving forward, and we're still in its infancy in terms of a strategic effort involving many different labs and instrumentation. And to answer at least some of these questions shown here, of course, there are very many more than that. But again, the important part is that this provides, again, ground truth. There are a variety of different samples that we're utilizing. One, we're examining the lithic fragments that were sieved during the preliminary examination and processing of the core. These lithic fragments are greater than 4 millimeters. We then also have the University of Manchester and Washington University St. Louis is also, as you saw, some of these beautiful images are doing analyses and imaging of these continuous cores, identifying a number of lithic fragments. Mike Okato is doing sieving of the less than 1 millimeter size fraction, and we're doing some work on identifying lithic fragments there. And then also, prior to getting our samples, when we didn't have that much to do, we went ahead and we started looking at the lithics at Station 2 Boulder, which we had in our collection, and some of the Station 2 and Station 3 surface samples. And this is just an overall view and to some degree simplified, but this is kind of the analytical pathway we're utilizing for the greater than 4 millimeter lithics, the continuous thin section, and then the less than 1 millimeter lithics. Again, they're providing a lot of information. Some of it's just illustrated here. What I'd like to do now is focus upon some of the different lithologies that we find, primarily focusing on the magmatic lithologies. And what I'm going to do is go through a series of these, starting with the volcanic glasses, and try to put them both in a petrologic context and also place them within a ANCSA context in terms of what some of our plans for these are. And Scott Eckley, again, made these XCT images that I'm going to be showing. Yeah. And Uliana Gross, pulled them out and identify these and sent me emails. Oh, Chip, look what we got here. And the one to the left that Uliana found was in 73002. And it's a regolith breccia. And you can see there's so many of these incredible pyroclastic glass beads. And this one right here in 73001, you can see this lithic clast with a grouping of glass beads. We don't really know what they are. I'm hoping that they're pyroclastic glass beads. And to the left, we also, during our sieving, we pull out a number of beads to pluck out, provide some of them, hopefully, to Darby Dyer. And that just shows 3 glass beads there. And what we're kind of doing, I want to place these within the context of both petrologic context and ANCSA. What we can get from these glass beads, as you've seen over the last couple days, is Darby can do measurements such as water, FO2 characteristics of the individual glass beads. There are a variety of imaging that can be done on surfaces to look at surface features of the glass beads, to look at volatile deposits. And then there's another petrologic context. And this is just a diagram from John Longy that he did, I think, in the late 80s, early 90s, that show liquid lines of descent for various basalt compositions. And on this diagram, all the black data points are all pyroclastic glass analyses, either derived from John Delano or me. And we did also a number of trace element analyses. And this just illustrates that, that potentially many of these pyroclastic glasses can be parental to more fractionated basalts. However, there is a problem. In our work, we have found very few links between the glasses and the crystalline basalts. Also, another point, on the Apollo 17 site, we identified, I think, 3 different types of orange glass, 1 different type of a black volcanic bead, and then a couple of very low titanium basalts. So we're looking out for those. This is another image as we go to the high titanium basalts, and this is an image to the left. And while that's being shown, I want to comment on the 2 images to your right. One is that most of the high titanium basalts we've looked at thus far are actually on the liquid line of descent that's kind of at a 45-degree angle to the high titanium basalt field, where it says armalcolite, ilmenite, pyroxene, plagioclase. That's a sequence of crystallization. And most of these ones that we've looked at thus far have very little olivine. There is some suggesting that it's further down the olivine liquid line of descent. What our goal is here is to really look at the where some of these basalts plot on this liquid line of descent, because it's very, very important to differentiate, if we want to differentiate different types of basalt and different source regions. The diagram on the bottom is from Clive Neal and just illustrates some of the diversity, not in the ANCSA samples, but what he and I found with regards to the crystalline Mari basalts and the pyroclastic glass beads. And this just illustrates that they're offset, essentially, again, indicating that the conclusions by Longy and I much earlier, indicating that these were unrelated to source, to the same source region, and that there is also diversity within the crystalline Mari basalts that Clive noticed, type A, B1, B2, C, and D. And hopefully what we're going to do is approach the other basalts fairly similarly from the core. This just shows some of the textural variation from the first 3 to your left. This is from the finer fraction that we sieved. And these are some of the unusual basalt textures that we see here. The two images to your right, and again, notice this, the scale is quite a bit different. We see, again, a fairly coarse-grained ilmenite basalt at the top right, and then something that's really unusual that that Clive pointed out, we have a basalt with appears to be two different types of basaltic melts with different cooling histories. Now what I'd like to do is move on to the low titanium and very low titanium lithologies. And you can see on, again, this titanium TiO2 versus magnesium number diagram. They're at the lower part of the diagram at low TiO2. There are only a few identified in the samples that have been looked at thus far prior to ANCSA. And these include things like the low titanium glasses and the deep drill core, and also some of the green glasses that Delano and I have found. That looked like what you just saw, probably a very low titanium glass, a low titanium Ari basalt.
2-minute warning, Chip.
Okay. And this illustrates some other textures that you will see in this low titanium basalt suite. In addition to that suite, we identified a wide range of other materials. Because of Clive's comments during the workshop, I kind of label them plagioclase plus olivine plus or minus spinel. As you notice, their grain size is fairly small. And so those are interesting features that we've identified. And if you actually analyze the olivine and the plagioclase, they do plot in the magnesium sweet field. And I'm not sure at this time what that means. Also, we found quite a number of anorthosites, and these were fairly coarse grained. Now let's go on to the next to the last slide. These are kind of lithologies that seem to be enriched and incompatible elements. There's a marvelous sample on the far left. It's an orthoperoxenite with plagioclase and 2 phosphates. The group at University of Manchester on the bottom left identified a plagioclase quartz potassium-bearing rock. And we also identified, as you can see on the right, a number of rocks that I will refer to as felsites. But again, their origin is still a point of debate. Even the individual samples that we've looked at, are they mesostasis from basalts, or are they actually felsic lithologies? And then what I'll do is I'll leave you with these observations and conclusions, at least from the images that I showed you. And again, the large lithic fragment group for ANCSA will try to resolve and answer some of these questions that I have here. And hopefully we'll be moving along, looking at these over the next several years, maybe. Thank you.